Namaskar, hello and a very warm welcome to CIET NCERT's live phone-in interactive program of Science for all the 9th class children. We are here with the topic Types of Mixtures. अगर आपके पास कोई सवाल है, कुछ पूछना चाहते हैं इस विषय से जुड़ा हुआ तो हम तक ज़रूर पहुंचाइए। आप हमें फ़ोन कर सकते हैं, नंबर है 8800440559। अगर ईमेल के माध्यम से अपने सवाल पहुंचाना चाहें तो वो होगा dth.class9@ciet.nic.in। इस वक्त आप हमें देख रहे हैं eVidya चैनल नंबर 9 पर। मैं हूं तन्वी खुराना और हमारे साथ हैं एक मेहमान मौजूद जो आपको सारी जानकारी देंगी टाइप्स ऑफ मिक्सचर्स के बारे में। तो चलिए आपका परिचय करवाना चाहेंगे मिस नेहा लहरिया से। मैम, अ वेरी वार्म वेलकम टू यू।
Good afternoon, ma'am. Thank you so much.
Thank you. Good afternoon to you too as well. Ma'am is a TGT in Science from Navy Children's School, Mumbai. And we are going to begin this discussion very soon, but let me quickly tell you that we are extremely proud of the fact that India assumed G20 presidency and would convene the G20 Leaders Summit for the first time in the country this year, that is 2023. A nation deeply committed to democracy and multilateralism, India's G20 presidency would be a watershed moment in her history, as it seeks to play an important role by finding global pragmatic solutions for the well-being of all, and in doing so manifest its true spirit of Vasudhaiva Kutumbakam, or should I say the world is one family. Vasudhaiva Kutumbakam also translates to one earth, one family, one future, and that is exactly the theme of this year's India's G20 presidency. तो चलिए इस बातचीत को शुरू करते हैं and let me ask ma'am, our topic is types of mixtures. So what are those types of mixtures that we are going to talk about and how many types are there, ma'am?
So today we are going to be discussing about 3 types of mixtures.
Okay.
They are true solutions, colloids and suspensions. So this is part of the second chapter of our science textbook, Is Matter Around Us Pure?
Okay, so shall we begin discussing those types?
Yes, sure ma'am. So before we dive into this topic, all of us need to know what are mixtures and what are pure substances, the difference between the two. So a pure substance is basically a substance which consists of a single type of particle. So throughout the substance, there will be only one type of particle. So examples include gold, copper, oxygen, chlorine, etc. So all these substances, if you look at the particles inside them, they are of a single type. On the other hand, mixtures, they are constituted by more than one kind of substances. So we can say that mixtures are constituted by more than one type of pure substance. So examples are seawater, air. As we all know, air is a mixture of many gases like nitrogen, oxygen, etc. Ink, it is a mixture of dye. And gunpowder, as you can see, it is a mixture of sulfur, potassium nitrate, carbon. So mixtures are constituted by more than one kind of pure substances. We have 2 kinds of mixtures, which are homogeneous and heterogeneous. So a quick introduction about these two. A homogeneous mixture is one in which the components are spread evenly throughout the bulk of the mixture. So there is a uniform composition throughout. And the opposite of that is a heterogeneous mixture where the components are not evenly distributed and it is distributed in a non-uniform way. So let us dive into today's topic and we are going to cover these 3 kinds of mixtures: true solution, suspension and colloid. So we begin with the true solution, and first of all we should know that a true solution is a homogeneous mixture of 2 or more substances. So that means the components of a true solution are evenly distributed throughout the bulk of the medium. The size of the particles, they are smaller than 1 nanometer in diameter. So they are so small that these particles cannot be seen by naked eyes, and they also do not scatter a beam of light that passes through the solution. The 2 components of a solution are solute and solvent, and the solute is the component which is present in a smaller quantity. The solvent is the component which is present in a greater quantity. So if you see at the examples given below, the first one is a sugar solution. So in a sugar solution, the solute is the sugar because it is present in a lesser quantity, and the solvent is water. Another important point regarding a true solution is that it is a stable mixture. Now you may be wondering, what do you mean by stable or unstable? So a stable mixture is one where the components do not separate out on their own, or we can say they do not separate out spontaneously. So if you see a sugar solution kept on a table undisturbed, you will see that the sugar does not separate out on its own from the water. So this means that a true solution is stable. So we cannot separate the components by simple processes like filtration. Other examples of true solutions are given as a salt solution, tincture of iodine, which is an antiseptic used in hospitals, where the solute is iodine and the solvent is alcohol. We have our aerated drinks, which are the cold drinks that we have, and air, as I mentioned in the previous slide. So here is another example of a true solution, which is a copper sulfate solution. So it is made from a copper sulfate crystals and which are dissolved in water. So these crystals, they get dissolved and they are evenly spread throughout the bulk of the medium. That's why it is a true solution. Now we move on to the second type of mixtures, that is a suspension. And it is a heterogeneous mixture in which the solute particles do not dissolve at all. The solute particles instead, they remain suspended throughout the bulk of the medium. So the particles of a suspension are way larger than a true solution. They are larger than 1000 nanometers in diameter. So naturally they are visible to the naked eye and they also scatter a beam of light passing through the suspension. Now as we discussed previously, what do you mean by stable and unstable? A suspension is unstable because if you leave a suspension undisturbed for some time, the solute particles will settle down on their own. So an example is a mixture of chalk and water or muddy water. If you mix some mud into water and keep it undisturbed for a few minutes, you will see that the mud starts to settle down at the bottom. So naturally the components can be separated by the process of filtration or even decantation. We have a few more examples of suspensions like mixture of flour in water, mixture of dust particles in air. Milk of magnesia is a suspension and milk of magnesia is also known as magnesium hydroxide. So here is an example of suspension, muddy water. As you can see, the mud particles are suspended throughout the medium, but if you leave it undisturbed for some time, they will settle down. Now, an important thing to remember about suspensions is that the particles, when they are suspended in the medium, they do scatter light. But when they settle down at the bottom, they are not able to scatter light because then the medium consists mainly of the solvent which is present on top. So here we should know something about the Tyndall effect. I've been mentioning scattering of light since the past two slides, and this effect is known as Tyndall effect, named after the scientist who studied it. So in the first diagram, you can see that a torch is switched on and the light is shined through two solutions. The first one is a true solution and the second one is a suspension. And in the second one, the path of light becomes visible because the particles of suspensions are able to scatter light. And an example that we can see in our everyday life is the second picture. That is, we can see the sun's rays in a very dense forest, the rays shining from the canopy of trees above. And you also must have noticed in a dusty room from a window, you can see the rays of light coming in from the window. So these are examples of Tyndall effect that we can see in our everyday life. So the last type of mixture that we need to know about is a colloid. Now a colloid is a mixture which has the properties intermediate between a true solution and a suspension. So if you see a colloid in a beaker or in a glass, it appears to be homogeneous, but it is actually a heterogeneous mixture. The particle size is between 1 to 1000 nanometers. So the particles are invisible to the naked eye, but they are able to scatter a beam of light passing through it. That is, the particles do show Tyndall effect. The components of colloids are stable. So that means the components do not separate out on their own, and we need to employ special methods to separate the components. One such special technique is called as centrifugation, where the mixture is spun at a very high speed. So this results in the separation of the components based on the densities. So the component which is heavier, which is denser, it settles down at the bottom and the lighter component rises up. So as we had seen, the components of a true solution had special names given to them, that is solute and solvent. Similarly, components of a colloid are named as dispersed phase and dispersion medium. So dispersed phase is equivalent to the solute, dispersion medium is equivalent to the solvent. And based on the state of these two phases, we have various types of colloids which we can actually see all around us. So the first one is where the dispersed phase is a liquid, dispersing medium is a gas. So we have liquid particles which are suspended in a gas, and this type of a colloid is called as an aerosol. And examples given are fog, clouds, mist. So we all know that fogs, clouds, mist, they are all water vapor which are suspended in the air. So this kind of a colloid is called as an aerosol. When the dispersed phase is a solid and the dispersing medium is a gas, again the type of colloid is called as an aerosol, and examples for this is smoke, automobile exhaust, the pollution which comes out from the factories. All these kinds of colloids are called as aerosols. When the dispersed phase is a gas which is dispersed in a liquid, so we have gas particles dispersed in a liquid, it is called as a foam. And the most common example that we have seen is a shaving cream or any foaming face wash that we use. And sometimes in our homes, we must have also seen when we add a little excess of detergent in the washing machine, you can see the foam rising up. So that is a type of colloid where gases are dispersed in a liquid. When both of them are in liquid state, it is called as an emulsion. The most common example is milk. Face creams, moisturizers, they are all emulsions. When the dispersed phase is a solid and the medium is a liquid, it is called as a sol. Example is milk of magnesia, mud. As I mentioned before, milk of magnesia is actually magnesium hydroxide. So these are solid particles which are dispersed in a liquid medium. The next one is a gas dispersed in a solid, and we call that as a foam. So if you see the examples, foam, rubber, sponge, pumice, they are all solids, but they all have air cavities in them. So we call that type of a colloid as a foam. When it is a liquid dispersed in a solid, we call it as a gel. So examples are jelly, cheese, butter. We have seen them all in our daily lives. And lastly, when it is a solid dispersed in a solid, it is called as a solid sol. Examples are colored gemstone and your milky glass. So I have two examples in a picture format, milk and mud. These are two types of colloids that we see every day around us. So if we go back to the separation technique of colloids, we know that we use centrifugation to separate the components of a colloid. So in a milk, the main two components are the fat and the rest of the milk, which we call as a skimmed milk. So whenever milk undergoes centrifugation, the fat comes up on the top because it is lighter, and the skimmed milk being denser, it settles down at the bottom. So now, after talking about all the three kinds of mixtures, I have a question for the audience. And the question is, seawater can be classified as homogeneous as well as a heterogeneous mixture. Why?
Okay. So, ma'am, maybe this could be the homework for all our children, and they'll be replying to this very, very soon.
Yes.
Okay. Regarding the same, ma'am, can I ask you a question? I have a query.
Yes, ma'am, please.
So, when you were showing us the chart for aerosols and other particles, you mentioned that there's smoke, there's fog, then there's mist, clouds and automobile exhaust. All were categorized as aerosols only. So, how are they different? They were written in different categories.
If we take the example of smoke and fog, we know that both of them are aerosols. The dispersion medium is the same. The particles are dispersed in a gaseous medium, that is air. The only difference is in the dispersed phase. So in smoke, the particles which are dispersed are solid particles. They are solid carbon particles. which are dispersed in the air. But in the case of fog, it is actually liquid particles, which is water vapor, which is dispersed in air. So the only difference is the dispersed phase. The medium is the same for both of them.
Okay. And ma'am, you mentioned that colloids, they are heterogeneous. But what about alloys? Are they homogeneous or are they heterogeneous? And can you give a reason for that?
Yes, ma'am, sure. So alloys are homogeneous mixtures because alloys are made up of two or more metals. So the
Okay.
most common example is brass, which is an alloy of copper and zinc. So when we make an alloy, we need to melt the main metal. So in brass, the main metal is copper, and in molten form, we add the zinc metal. So in molten form, they are able to distribute evenly throughout the mixture. And upon solidification, you can see that the whole alloy is a homogeneous mixture.
Okay, all right. Now this makes more sense. Could you please continue where you left?
Yes, so now we have actually reached the end of our topic, types of mixtures. And I would like to end by giving this question as a homework.
Okay, so seawater can be classified as homogeneous as well as heterogeneous mixture, and the students have to state a reason why is it so. Sure, ma'am.
Yes.
I'm very sure that the students are going to answer this, and on our email IDs as soon as they can, we'll be discussing on that. Ma'am, I have one more question for you, so may I?
Yes, ma'am, please.
So you explained the particles of suspension that they settle down, and the colloids don't. Can you tell us why is it so?
Yes, so we mentioned the stability of a mixture. The components separate out on their own in suspensions and they don't in colloids. So this is mainly because of two reasons. The first reason is the size of the particles. So as we have mentioned before, suspension particles, they are greater in size, and due to the effect of gravity, they settle down. Whereas colloidal particles are not that big in size, they are between 1 to 1000 nanometers. So they remain in the solution. The second reason is because colloidal particles are in a constant zigzag motion, which we also call as Brownian motion. So what happens is colloidal particles collide with each other, and because of that motion, they are not able to settle down. So because of these two reasons, suspensions are unstable, but colloids are stable.
Okay, ma'am, can you explain the Tyndall effect a little more clearly once again?
All right. So we mentioned the stability of
Yes.
mixtures. When a mixture's components separate out on their own, we say that the mixture is unstable.
Okay.
And when they don't, we say that it is stable. So there are two reasons why particles of a suspension settle down. The first reason is the size, because the particles are greater than 1000 nanometer in diameter. They are so big that they settle down under the effect of gravity. The second reason is that the particles of a colloid are in a constant motion due to collision with each other and the medium. So because of this constant zigzag motion, which we also call as Brownian motion, the particles are not able to settle down. So these are the two reasons why suspension is unstable and colloids are stable.
Okay. Ma'am, before we leave, the question you have given for homework to all our children, would you like to discuss its answer as well?
Yes, ma'am, sure. So I hope the students have got some time to think about the answer. So I will be providing the solution as well.
Okay.
So here is the answer. The seawater is a mixture of salts and water. Because the salts are dissolved in water, it can be considered as a homogeneous mixture. But apart from salts, there are also many other components in seawater, such as mud, decayed matter, such as dead plants, dead animals. So these components are not evenly distributed in seawater. And because of these components, seawater can be classified as heterogeneous too.
Okay, all right. Thank you. Thank you so much, ma'am, for being a part of this program. We've learned so much about these types of mixtures, and I'm sure the students, they must have found this conversation very interesting. Thank you once again for being with us today.
Thank you, ma'am. Thank you so much.
Thank you to all our viewers for watching this program. I really hope that you enjoyed, and if in case you have missed it, you can always watch it on our YouTube channel. So for now, we're wrapping up this particular program, but coming up next is an English class for all the 9th class children, and the topic of discussion is going to be "A Slumber Did My Spirit Seal." What is it? You will get to know in the program itself. Please keep on watching eVidya channels. We have got a lot of programs for all of you on different subjects, on different topics. So do watch and add it to your knowledge. I'll take a leave of you, but before that, let me just tell you that if you have not purchased NCERT textbooks for now, please purchase it because they are available now throughout in the country. For this new academic session 2023-2024, you can either download the PDF versions from NCERT, Diksha or ePathshala website or their mobile applications, or you can go to the website and place an order. The website is ncertbooks.ncert.gov.in. Place an order and the books will reach your doorstep in no time. You do not have to pay anything extra, any delivery charge at all. And also, if you want to go to the sales counter, you can do that from 9:30 to 6 p.m. The sales counter are open. You can visit on any of the days, be it a weekend, be it a weekday or any other holiday as well. They are open throughout. They are located in New Delhi, Bangalore, Ahmedabad, Kolkata and Guwahati. So there are multiple mediums through which you can purchase these books, and for authorized vendors you can go to the website ncert.nic.in and look at the list of the authorized vendors. Thank you so much once again. Have a great day ahead. I am Tanvi Khurana. I'll take a leave. Namaskar.